Hi, welcome again. After we set up our project in the previous video, let's start this tutorial by saving data in the database. So, let's add the click event to the add button and use Axios to send a post request with the data from the HTML form. Now, let's add the post method on the server side. Now we need to create a constant that reference to the database. In Firebase Realtime Database, data is stored in JSON format, and each node of the JSON tree is a reference. Every time we go deeper in the tree, we have to use the slash to indicate the path of the child node that is nested inside a parent node. So, back to the code. To add new data to the database, we need to create a reference, then use the set method. Set accepts an object as parameter which contains the data we want to save in the database. The save operation didn't work because we have something important to set, which is the database roles. Roles basically decide who has the access to the database and what privilege each user has. That said, roles play a huge role in the security of your database, so you have to make sure to set them the right way. Let's try another test, and let's see if the save operation will work as intended. References can be split then reconstructed using the child method, which makes the code cleaner and more readable. Up until now, we were creating user IDs manually, which is a really bad practice. So, to generate them automatically, we have to use the push method, which will create a new reference using a unique key. Then, use the key property to get the key. Let's add the click event to the update button and use Axios to send the put request with the data we want to use. Now, let's add the put method and the callback function in the backend. That done, to update data we have to use the update method on a reference. Update takes an object that contains the new data that we want to use to override the old one. With update, we can also save data in multiple references in the database at the same time. So let's say we want to add a user in the user's reference and the same user in a super user's reference. First off, we need an object that holds the data to save. Then, of course, a unique ID. Then, an object that will hold the different references in the data to save. And finally, use the update method and set the references object as parameter. Same as previously done with the add and update buttons, let's add the click event in the callback function to the remove button. Same thing goes in the backend code. To delete data from the database is pretty simple. We just need to choose the reference we want to delete and call the remove method on it. Firebase Realtime Database has listeners and events that basically mean that these listeners will keep an eye on a reference, and whenever an event occurs, a callback function will trigger. On is the listener method. Then we have the first event, which is the child added event, which as its name suggests, it triggers the callback function whenever a new value is added to the reference. The second event is child changed, which will trigger the callback function whenever an update occurs inside the reference. Child removed is another event which will trigger the callback function whenever a child gets deleted from the reference. Finally, there's value, which will do all the previous, along with another event called child changed. There is also another listening method, which is once. This method will listen to an event only once, so it will not trigger the callback function if the same event occurs again. The callback function's parameter, which I called snapshot, contains different information like the new data values, childs, and key. So, if we want to get the new values catched by the child changed event, we can use the val method in the snapshot object. A query in Firebase Realtime Database is composed of a reference, an ordering function, and a querying function. The first ordering function that I'll use here is order by key, which will order the childs of the reference based on their keys. As we didn't use a querying function, the result we got is the same as the data in the reference, so let's use the limit to first querying function. Now, the result that we got contains the two oldest objects after the comparison of all the keys of the reference, since the auto-generated keys are based on the date and time of when they got created. Limit to last does the reverse, so the result contains the two newest created objects. Order by child is probably what you will need most. It orders the objects of the reference based on the value of a certain property. Same as the previous ordering function, using it without a querying function will return the same data in the reference. Now, if we want to get the two youngest users, we can use limit to first two. Then, based on the value of the age property, we will get the result that we want. We can get the oldest user using limit to last one. We can also search for an exact value using equal to, so it will return the object that matches that certain criterion. The start@d querying function is a bit tricky. Start@d in this example returns every last name that starts with the letter D and whatever letter that comes after the letter D. Start@j will return every last name that starts with the letter J and whatever letter that comes after it. Finally, order by value is used on references that contain comparable values. You can find the project files at the GitHub link in the description below. So, this should be enough to get you going with Firebase Realtime Database. So make sure to subscribe and hit the bell notification, and see you in the next video.